Okay, it's time for us to get into the study of Verilog. Actually, Verilog is a language. It's a hardware description language that can describe the function of a digital circuit. The use of the language is to enable you to design large-scale design circuit with high work efficiency. So begin in the beginning of digital circuit design, such as 1980 or 19 okay almost 1980, designers have to draw circuit schematics to design the circuit. They have to use the basic logic cells such as NAND gate, exclusion OR gate, mux, and clicking them up to make the digital function. This is very hard and hard to control and hard to design large scale circuit. So some scientists invent the Verilog language. And there is some similar languages we can use now, such as VHDL, System Verilog, Chiso. System Verilog is a superset of Verilog. Okay. All the syntax in Verilog is supported in System Verilog, and it adds some other new syntax. Chiso is a language common with RISC file. Yes. Yeah. The group defined RISC file architecture also invented Chiso language. We usually call the code written by Verilog as RTL code. What does RTL represent for? It represents for register transition level. So what is register transition level? That is, in the code, you have to describe the register values of each cycle. You have to tell the value of all registers for every cycle. As you have defined the value of registers for every cycle, you can have the value transition of each register. Yes, you can have the value transition of each register. So this is called the register transaction level description. Okay, for the sensitive part, we usually use RTL level description. But for the test bench part, for the test bench part, we can write the code in a more abstract level. You don't need to describe the register transaction. You can just focus on the function, focus on the or just describe the algorithm that you want. That is something like you're doing the C programming language. Yeah, C programming language. Okay, this is just some words. If you want to know it deeply, we will give you many examples in the later sections of this chapter. Okay, many examples on RTL and on test bench. Then you can have better understanding the difference between RTL and test bench coding. So for test bench, we can call it behavior level coding. Or you can say coding and behavior level. Okay, coding and behavior level. If you want to study more about Verilog, except this video, you can refer to this book. I think this is a good book for beginner. There is one important note here. Verilog is just a description language. Okay, keep in mind, Verilog is just a description language, not design language. Okay, how the design will be looks like, how to implement the algorithm or implement the CPU core. Designer must plan and architect it before coding it. So you have to plan and architecture the circuit before coding it. Okay, you will have better understanding of this in the examples and the coding exercise in this course. Okay, let's see our first Verilog program, Hello World. For every language, this is usually the first program. This is a program with only 5 lines. Okay, you can see the orange highlight words are keywords. Okay, the orange highlight words are keywords, such as this. These are keywords in Verilog. All the blocks defined in Verilog is begin from the module keywords and end with end module keywords. That is, you define a block of function. Okay. You can say a digital circuit block, or something like that. So use module and end module to form this block, and you usually give this block a name. This is module name. Okay, you give it a name, then you can write statements. You can write statements in this module. So in this module, we just have one procedure block called the initial block. So initial is a keyword. It identified that this is the initial procedure block, and an initial block is always begin with the begin keywords and end with the end keywords. Okay, inside this block you can write many statements one by one, like you write the C statements. And each statement will end with this symbol, okay? And how about this round brackets? Actually, in the round brackets after the module name, you can define the input name and output name of this block. So you can, if there is any input and output, let's see some. Okay, this is the angle. If this block has some input and output, you can put the name in the round brackets after the module name. Okay. And this module, as we don't have input and output, we just left it empty. Okay, and so what's the meaning of initial? It means when it's power off, when it's power on, or the simulation run up, it will execute the statements in the initial procedure block one by one. So that means at the simulation 0 time, for example 0 nanosecond, the statements in this initial block will execute one by one. This is the initial means. initial, yeah, from the beginning. Okay, so from the beginning of simulation, the statements within the initial block will execute one by one. Okay, let's say the mean of this dollar display. This is something like the print function in C language. The dollar means the function after it is the Verilog language defined function, not a user defined function. Okay, and the function of display is print these words in the terminal. Yeah, the same as print in C language. That's all for this code. Okay, do you think Verilog is simple or difficult? Actually, in this small code, you have learned about 10% of the commonly used Verilog syntax. So it's not very hard. Now you have code, and you must want to run the code to see what's the behavior of the code. Like you have some C program code, you want to use GCC compiler or wish C++ to compile the code and run it. So for Verilog, we also have the simulation tool to do the simulation. That is using EDA tools to compile and run the code in a PC or workstation to check the function of the code. Yeah, they are commonly used in the company's IC design house, and this is free, so it will be quite suitable for study. Okay, Verilator. So in this course, we'll use Verilator to simulate the code. The ideal or the usage of these tools are almost the same. You learn one and you can adapt it to the other very quickly. After you validate the function of the code, you may physically implement it in ASIC chips or in an FPGA device. So you will use Synthesis tool to translate the code to the basic logic gates and place root the cells. Then you will get the physical implementation. Okay. What's the difference between ASIC and FPGA? You can Google it. Okay, this is a note. As we have mentioned before, a digital circuit and simulation is actually a four-state value. For each bit, it has 4 values. But for Verilator, the version until 2024 just support 2-state value. So if there is some X or Z value in your code, the tool will automatically convert it to 0 or 1. Okay, this is not accurate, but for most of the design, it should be okay, as X actually is not allowed in our design, and Z only be allowed at the I/O pad. So for most of the cases, this should be okay. And the problem is, if you miscoding something and cause X in your design, this can't be identified if you're using Verilator. Okay, you can't identify X value. That is a mistake in your design by Verilator. But if you use this array, you can identify the X problem in your design. Okay, so if you can access these tools, you can use these tools to run the code exercise in this course. And for Verilog code, we usually divide it into two categories: the synthesizable statements and the non-synthesizable statements. What is synthesizable statements? It means using synthesis tool. A synthesis tool can translate the code statement to the basic logic cells and keep them function equivalent. For example, if you write this code in your Verilog, after synthesis, it will be changed to an AND gate. Yes, it will be changed to an AND gate, and the input-output will be collected as you described in the Verilog code. So the input will be collected to AB, and the output of the AND gate will be collected to Y. And this is a keyword. Assign is a keyword in Verilog. We'll explain it later. So you can understand the meaning of this line is use logic and operation on AB signal and assign the output value to Y. Yes. So the code and the logic, the synthesis logic is function equivalent. And some statement can be non-synthesizable. That means tool can't compile these statements to basic logic cells. For example, the code we have seen before, a display function call. This function call can't be compiled to some simple logic, to some basic logic cells. So this statement is non-synthesizable. Actually, if you are familiar with, if you have used some MCU core, you may know this statement. If you want to print some characters on the screen or on the terminal, in an MCU, you usually use the UART. You have to usually use the UART block. Yes, you have to write some program running on the CPU. Then the CPU will control the UART block to print these words or to send these words out. The execution of this statement involves many parts of our circuit. It can't be translated to some basic logic gates. So this statement is not synthesizable. Okay, for synthesizable or not, it's not only relying on the syntax you used. That means the same syntax can be synthesizable in one place and not synthesizable at other place. Yeah, so just keep in mind, synthesizable or not just rely on the syntax you use. Okay, it also rely on the usage of this syntax. So maybe you can understand the meaning. I will give you some examples later in this chapter. Okay, that's all for this section. Next section, I will explain how to install the validator and the wave viewer GTK wave. Okay, then you can code this and simulate it in validator. So to study Verilog well, you have to do many exercises to code as many as possible. Code it, run the simulation, and debug it. This is a good way to master Verilog language.